Geometry, Unit 4, which is Chapter 9 from the book, Section 3, Special Right Triangles. So we're going to look at the isosceles right triangle conjecture. In an isosceles right triangle, if the legs have length x, then the hypotenuse has length x square root 2. So let's prove this idea using Pythagorean theorem. All right, so we know it's isosceles, so those are congruent. So x squared plus x squared, does that really equal x square root of 2 squared? Okay, so x squared plus x squared, that's 2x squared. All right, x squared, that's x squared. Square root of 2 squared, remember, square root and square, they cancel each other out, so it leaves you just 2. So it does work out. That is true. All right, so let's solve a couple of these problems. So we know it's isosceles. So if one side's 10, the other side's got to be 10. So 10, 10, so this guy is going to be 10 square root of 2. We could go through Pythagorean theorem to prove that. 10 squared plus 10 squared equals c squared, so that's 100 plus 100, so that's 200 square root of that. Well, that ends up being 10 square root of 2. Okay, so let's work it the other way. Well, what if the hypotenuse is 10? What are the other sides? Well, that ends up being pretty simple as well. 5 square root of 2. So where did 5 square root of 2 come from? I divided this by 2, giving me 5, and then adding that square root of 2. Let's check that. Let's make sure that actually works. 5 square root of 2 squared plus 5 square root of 2 squared, does that equal 10 squared? 5 squared is 25 times square root of 2, which is 50. 5 squared is 25 times 2, which is 50. 50 plus 50, does that equal 10 squared? 100? Yes, it does. So there we go. Now let's look at a 30, 60, 90 triangle. 30, 60, 90 triangle, let's think back to a equilateral triangle. All angles are 60 degrees, and if each side is 2x, we know they're all going to be congruent. Now, if I draw the altitude down, I know that ends up being 30 degrees. Now, an altitude of an equilateral triangle splits those two sides into equal lengths. So that ends up being x. So let me take that thought over here. If that's 2x, that's x. Well, that still leaves me with, well, what's this side? Well, let's do Pythagorean theorem. X squared plus b squared equals 2x squared. So x squared plus b squared equals 4x squared. Subtract x squared. Square root that. B equals x square root of 3. So this side, instead of being b, is x square root of 3. So if I divide by 2, that gives me that side, and then I multiply by square root of 3, it gives me that side. So let's solve these. Divide by 2 gives me 5. And then multiply by square root of 3. I get 5 square root of 3. And we could check that using the Pythagorean theorem. Times 2 times square root of 3. Again, we could check both those using the Pythagorean theorem, and it does work out. All right. Now we got to work the other way around. So to get this one, instead of times my square root of 3, I divide by square root of 3. So 9 divided by square root of 3. Times by 2. Now we don't like having radicals on our denominator. And now we're going to look at how we can rationalize our denominator. In other words, get rid of the radical on the denominator. So let's look at how we do that. Oh, sorry. Let's look at how we do that. So we're going to rationalize this. We're going to multiply by square root of 3 over square root of 3. We get 9 square root of 3 divided by square root of 3 times square root of 3 is 3. So 9 divided by 3, we end up 3 square root of 3. So this is 3 square root of 3. This ends up being 6 square root of 3. All right, so let's go do some more simplifying of radicals. 4 square root of 5 plus 7 square root of 5. I can add them because they have the same radical. So 4 plus 7 is 11 square root of 5. Now these ones I cannot currently add. 3 square root of 2 plus 4 square root of 8. I can't add them because the radicals are not the same. What I can do is I can simplify 4 square root of 8. So 4 square root of 8, 8 is 2 and 4. Well, I know 4 reduces, so that's 4 square root of 4 times square root of 2. 4 times square root of 4, that's 4 times 2 is 8 square root of 2. So now I can add those. 3 square root of 2 plus 8 square root of 2 is 11 square root of 2. Okay, let's look at these. Now, from just initial look, looks like we can't do anything with them. But let's go through the same thought process. Let's reduce these. Let's simplify them. 5 square root of 5. Square root of 125 is 5 and 25. We know that reduces. So that's 4 times the square root of 25 times square root of 5. So that's 4 times 5, which is 20 square root of 5. And then 20, let's see, that reduces 2 and 10, which is 2 and 5. So we know those reduce. So that's 3 times square root of 4 times square root of 5, which is 3 times 2, which is 6 square root of 5. And so I get 26 square root of 5. I can add them now. Now let's do these problems. 4 square root of 18 minus 4 square root of 12. So let's reduce. 2, 9. So 4 square root of 9 times square root of 2. 4 times 3 is 12 square root of 2. All right, 12, that's 2 and 6, 2 and 3. So that's 4. So that's 4 square root of 4 times square root of 3. So that's subtracting 8 square root of 3. And that's all I can do with it, because I cannot reduce the square root of 2, and I cannot reduce the square root of 3, so therefore I can't do anything more with it, and we are done. And that is the end of this lesson.